Hello again. So today we are going to look at some application problems of rational expressions, and I put up a word problem there for you. So take a look at it, pause the video, copy the problem if you don't have it, and then we can talk about it. Okay, so we have an airplane maintains an airspeed of v kilometers an hour between the two airports d kilometers apart. So I just put a diagram is very helpful in this case. So two airports, airport A, airport B, there are d kilometers in distance between them. Here it is. All right. Now it talks about on the outbound trip there is a headwind of w kilometers an hour. That's a small case w. And on the return trip, a tailwind. So this is the very important headwind and tailwind. Okay, so headwind coming against the original speed of the aircraft, and the tailwind is actually going with it, so pushing the aircraft, right? So one is w, the other one is also w. So the question is, write an expression for the time taken for the round trip. All right, so first we need to write an expression for the speed of the two, the outbound and return, and then go from there. So let's do that. Okay, so if the outbound speed, just the aircraft, is v kilometers, so v kilometers an hour, but because it's outbound, it tells you that on the outbound you have a headwind of w. So that means that the speed of aircraft is going to slow down by the factor the w. So you say minus w kilometers per hour. Okay, now on the return though, the velocity, or sorry, the speed, that's a physics terminology there, the speed, we call it v, kilometers per hour, is actually getting increased by the wind, the tailwind, and that is again w kilometers an hour. So these two are actually, so v minus w and v plus w are the two speed. One is for outbound, the other one for the return of the aircraft. All right, so now if you remember from your science classes, very basic one, the speed, the ground speed, is distance divided by time. That's what that is. That's why kilometers per hour, miles per hour. That's distance, total distance over total time that the given object is traveling. That's how you calculate the speed. All right, now we need the time. The question is, what is the time? We have to come up with the expression, with an expression that actually explains time. So we need to rewrite this speed formula in terms of time. And if you remember time, so it will be distance. So you just switch these two around, right? That's what we will do. And that would be distance divided by speed. All right. So here is, now we have to write up the expression for the time. So the total time will be, so the distance, we call it d, that's the distance between the two. So the first one is, we have to include the outbound, and the outbound speed is v minus w. That's the total time, by the way, t total. And then we have to add, because we want to know what the total time is coming back, the return, the distance is the same, d divided by, this time, v plus w. So this is the expression of time, total time, in terms of the distance and the speed, outbound speed and the return speed of the aircraft. Now that we have this, you need to go ahead and add the two rational expressions now. So just what we have done before, now you just want to add. So d over v minus w plus d over v plus w Now I put the denominators in a bracket. Now you have to go ahead and again add them. So lowest common denominators, and then do the whole thing that you have to do to add the two rational expressions. So go ahead, do that. So here is the LCD is V minus W, V plus W. That is your LCD. Okay, and multiply top and bottom each of the expressions by the factor that is missing. So V plus W for the first one and V minus W for the second expression. And then you have to multiply each of these guys through to expand, and then add and collect like terms. So let's do that. Once you do this, dV plus dW plus dV minus dW. And then so let's go now. dV and dV, they're the same. How many dVs do we have? We have 2 dVs. We have a dW minus dW, that's 0. So that cancels out. Okay, that means they just neutralize. That means that they become 0. And then the denominator is V minus W, V plus W. This is the final simplified time expression for this question. Okay, that is it.